Hey everybody! So in this video, I'm going to show you a couple of examples of how we calculate the area of different shapes. Some examples are going to be very similar to solving a PEMDAS problem where we actually have to find the area of the particular shape. In other instances, the area is going to be given to us and our goal is going to be to try to find the value of the missing piece of whatever shape it is that we're given to us. So to do this, we are going to need our formulas. So you may want to reference either a STAR reference sheet if you have one, or you can look back in your notes when we wrote down the formulas for the different areas or the different shapes and their area formulas that we had from a previous video in a previous class. So you will probably want to reference this if you don't know the formulas kind of like in your heart already. And you don't have to memorize the formulas. They're given to you pretty much like on any kind of assessment. So you don't have to memorize them. So the first question, it has a triangle and we're given the different parts of the triangle. So we're going to calculate the area. So to find the area of a triangle, according to our formula sheet, the area of a triangle is equivalent to 1/2 the base times the height. So I'm given the base and I'm given the height. So I'm going to plug in what I have. Area is 1/2 4 times 10, or you could have put 10 times 4. Technically, the base is 10 and the height is 4. So I kind of like flip-flop the order there. And now I'm just going to solve. It looks like a PEMDAS problem. So the area is equal to 4 times 10 is 40. And then 1/2 times 40. When we take 1/2 of something, that's the same as dividing it by 2. Just so you know, kind of a fun fact if you didn't know that. So 1/2 of 40 or 40 divided by 2 is 20. And we can say, like, let's pretend that this is centimeters. When we find the area of something, we're looking at the entire space that it takes up. So we say that our units are technically squared because this unit is centimeters and this unit is centimeters. And when I multiply centimeters times centimeters, that's the same thing as centimeters squared, just like how 5 times 5 is the same thing as 5 squared. So that's why we square our units when we have the area formula. So this area would be 20. Now, if we look at another example with a triangle, in this case, we're given the area and we're given the base. 12 is the base. And we need to calculate or figure out what is the height of the triangle. So if I use my formula, area equals 1/2 base times height, I'm going to plug in what I'm given. So 60 equals 1/2 12, that's our base, times the height, h. So now that I have what I'm given plugged in, I am just going to follow my 3-step process for solving equations. I'm going to combine any like terms, get rid of any buddies or constants, and then get rid of any coefficients. So I can combine this multiplication right here, 1/2 of 12, which is the same thing as just 12 divided by 2. So I'm going to rewrite this up here. So 60 is equivalent to 1/2 times 12 is 6h. 1/2 of 12 is 6. And now I'm going to solve. I can use my division property of equality because 6 times h, I'm using the opposite kind of math. So I'm going to use my division property of equality. 60 divided by 6 is 10. 6h divided by 6 is just h. So the height of my triangle is 10 units, whatever the units are. So this is an example of how I was given what the area was equivalent to, and I had to find the missing piece. So I essentially set it up and solved it like one of our equations. Okay, now let's look at some trapezoids. Trapezoids kind of look daunting, but they're really not that crazy. They just tend to be like an extra step compared to triangles and rectangles and squares and things like that. So in this problem, we're given our 2 bases and we're given the height of our trapezoid. So to find the area of a trapezoid, the formula is we're going to take 1/2 of the sum of the bases, our base 1 plus base 2, and we're also going to multiply it by the height. So for this problem, if I plug in what I have, area is going to equal 1/2. My bases are 5 and 10. So I could do 5 plus 10 or 10 plus 5. It doesn't really matter which is base 1 and base 2. We're adding, and we can add in any order and it's fine. And then the height is 5. So essentially what I got is a PEMDAS problem. So I'm going to solve what's in parentheses first. So 5 plus 10 is 15 times 5. So if I keep going, this is the same thing as 1/2 times 15 times 5 is 75. And so 1/2 of 75, or again, that's the same thing as just 75 divided by 2. This is going to be equivalent to, let's see, 75 divided by 2 should be 30. Trying to do it in my head right now. Some of you are like, Miss, it's this. Come on, it's so obvious. I believe it is it 36.5? I'm going to double check. I'm going to do some long division over here. My brain's not working right now. It's all foggy because of allergies. So 2 goes into 7 3 times. 7 minus 6 is 1. Bring down the 5. 2 goes into 15 7 times. Oh, I was close. It's 37.5. I could put a 0 here and continue the division. So this is equivalent to 37.5 units, whatever the units are. So the area of this trapezoid is 37.5 units, and we would square the units, whatever the units would be, okay? So in the last example, we have another trapezoid. So this trapezoid I didn't draw the best, but a trapezoid only has to have one set of parallel lines. So in this particular trapezoid, the bases are the parallel lines. In this particular trapezoid, the bases are also the parallel lines. This should be more of a straight line here. So in this particular trapezoid, we're given the area, the bases, and we're trying to figure out what the height is. So if the area is 72, 72 is equivalent to 1/2 plus our bases, so that would be 3 plus 5. Again, I'm just going back and using this formula here. I didn't write it down again, but it's 1/2 the sum of the bases times the height. So 1/2 our sum of our bases, 3 plus 5 times the height, which we don't know. So now, since I have more of an equation to set up and solve, like my variable is not isolated, I'm going to work to isolate this variable. So this is going to be equivalent to 3 plus 5 is 8. 1/2 of 8 is 4. So 72 is equivalent to 4h. So I can use my division property of equality now to solve. And h is going to be equal to 72 divided by 4, which I believe is 18. I'm going to double check that real quick, because again, my brain's not really working today. If I do 18 times 4, 2, 3, yes, 18. So the height of this particular trapezoid is 18 units. And I just used my formula and solved it like an equation to figure out what that missing piece is. So depending on what information you're given in area problems, sometimes it's a very basic PEMDAS problem. Other times when you're trying to find one of the missing parts of the shape, you solve it like an equation. And we still use those properties of equality that we've used before with equations to set up and solve.